Class example 3.22 is one of my favorites in this unit. It's very straightforward, can be done without a graphing calculator, but tests your knowledge of some of the key understandings of this unit. We're given the function y equals negative 3 times 4 to the x plus 48. We need to determine the domain and range, and then the x and y-intercepts. We should be able to do all of this without touching our calculator. First, the domain is x belongs to the real numbers. This is because there's no x value that is not permissible as an exponent on the 4. Recall in this course we have only 3 types of restrictions. We can't divide by 0, we can't take the square root of a negative number, and we can't take the logarithm of 0 or a negative number. There's no possibility of that here, so the domain must be all real numbers. For the range, we're going to think of 2 things. First, our k value will determine our upper or lower limit, as it represents the horizontal asymptote we're approaching. Here our k value is 48. Because our a value, that's the negative 3, is negative, we are below the horizontal asymptote. Our graph opens down. That means our range is y less than the horizontal asymptote height of 48. Next up, we'll determine the x and y-intercepts. Recall that an x-intercept is found by replacing y with 0, and a y-intercept is found by replacing x with 0. One error that happens sometimes we want to be aware of is that 4 to the 0 is equal to 1, but that negative 3 is not affected by the exponent of 0. So make sure you don't change that first term into a 1. It becomes negative 3 times 1 plus 48, giving us a y-intercept of 45. Our x-intercept is found by isolating the power term and determining which power on 4 is equivalent to 16. Here we find it to be 4 squared, so our x-intercept is at 2. You can confirm all of this with your graphing calculator, but again, a strong algebraic understanding and conceptual understanding of how exponential functions work will definitely serve you well.